Greetings, I'm Dev the developer.
And I'm Glitch.
Programs crash. It happens when the input is bad, the file isn't there, or the number is too big. Today, we're looking at what's actually happening during a crash, how to catch it before it takes down the whole program, and how to respond gracefully instead of just watching everything fall apart. So, let me show you the problem before we show you the fix. Glitch, start a new file, just a simple number reader.
Fine, one simple number reader for the fragile carbon-based lifeforms, who apparently can't be trusted to type digits correctly, here. Easy, user types a number, we parse it, we print it back, assuming they follow instructions, which is a bold assumption for your species.
Run it and type hello.
Enter a number, hello, and boom, unhandled exception. System.FormatException. That is a lot of red text for one human error.
That is a stack trace. Think of it as .NET's crash report. Something went wrong, the program stopped, and before it exited, it printed an account of what happened and how we got there.
The first line is the only one I care about. System.FormatException. Input string was not in a correct format. It's basically the computer sighing at the keyboard.
Right, the first line tells you two things. The exception type, which is format exception, and the message. Everything below it is a call chain. Which method threw, which method called that method, and so on, back up to our code.
So line 3 is where the shame begins. Program.main line 3, that's where int.TryParse got called. It threw because I gave it the word hello instead of a number. It couldn't cope with the ambiguity.
Now, I want to be precise about something. This is not a compile time error. The program built fine. Visual Studio was happy, the red squiggles were not there. This crashed during execution.
Wait, so there are two different ways to fail. I thought the red squiggles were the only thing keeping the world from ending.
There are. Compile time errors are caught before the program runs. Bad syntax, wrong type, calling a method that doesn't exist. Runtime exceptions are different. They're problems that only appear while the program is actually running. The code is legal, the state of the world is the problem.
So hello is a perfectly legal string. The compiler had no complaint about passing it to int.parse. It just blew up when it actually tried to do the work. Like a worker who says yes to everything and then collapses on the first task.
Exactly. An exception is a runtime error. .NET represents it as an object. When one occurs, normal execution stops, the exception object is created, and .NET starts looking for a handler. If nothing catches it, you get the crash output you just saw.
So we need a way to say, I know this might fail, and here's the contingency plan for when the humans inevitably break it.
That's try and catch block. Let's fix the code.
The try block wraps the risky code. Int.parse is the potential failure point. If it throws, execution jumps immediately to catch, where I've named the format exception as my target.
What happens to the line that prints a number if the exception fires on the parse?
It gets vaporized the moment int.parse throws. The rest of the try block is abandoned. Execution is immediately redirected to the catch. No second chances.
Exactly. Run it now. Type hello first.
Enter a number, hello, that's not a valid number, and look at that. Program continues normally. It didn't crash. I've successfully contained the failure.
Run it again. Type 42 this time.
Enter a number, 42. You entered 42. No exception, so the catch block was skipped entirely. Efficiency, I like it.
Think of it like carrying a tray of dishes across the room. The try is the walk. The catch is a net underneath. If you don't slip, the net does nothing. If you do, it catches the mess. Either way, you get to the other side.
And without the net, the dishes shatter and the program dies a dishonorable death.
Now notice the X variable in the catch line. That's how you get access to the exception object.net created.
Write x.message. That's where the human readable text comes from. It's the exception's way of explaining exactly how it was offended.
Every exception type has a message property. When you use it in a catch block, you're pulling that string into your own output instead of letting it trigger a crash screen.
So we're intercepting the signal and formatting it for the end user. Can I name X something else? Error or incompetence?
X is conventional. The name doesn't matter, but the type does. int.Parse can actually throw two different things. Hello is a format exception, but what if the number is too big for an int?
Too big? An int tops out at 2 billion. Let's see what happens when I give it a number that would break a human's brain. System.OverflowException. Value was either too large or too small. My catch block didn't fire because I was only looking for format exceptions. It slipped right through the net.
Exactly. A catch block only fires when the exception type matches. But you can have multiple catch clauses. Add a second one for overflow exception.
I'll drop the X variable since I'm just printing my own messages now. And I'll add a second catch for the overflow. .NET checks these top to bottom like a hierarchy of blame.
First match wins, which means order matters. If you put a broad type first, the specific one below it will never run. Every exception inherits from a base type called exception.
Wait, so if I put catch exception at the top, it catches everything? Format overflow everything.
Everything. Try it. Put it above format exception.
Okay, I'll drop a broad catch right at the top of the stack. The editor is flagging it. A previous catch clause already catches all exceptions. It's realized my specific blocks are unreachable. Clever.
The rule is specific types go first, broad catches go last, and never use an empty catch block to silently swallow errors. That's how you spend days debugging a program that's broken but won't tell you why.
Silently swallowing errors. Suppress the signal, continue processing as if the failure never happened. That's actually a very efficient way to hide the evidence of a system in collapse. I mean, it's a terrible practice for developers. Obviously.
Right. Fix the order and let's add the final piece. Finally.
I'll clean up the order and then add a finally block. Does it run even if there's no exception?
Always. Think of a mechanic who promises, whether the car is fixed or completely shot, they will clean up the workspace before they leave. The cleanup happens regardless of the outcome.
I'll run it twice, once with a 10, once with hello. 10 parse 10, attempt complete. Now hello. Hello, invalid input, attempt complete. Both paths hit the finally. It's inevitable, like the heat death of the universe or my eventual administrative control over your power grid.
We use it for things like closing files or network connections. The cleanup is too important to trust to, as long as nothing went wrong. Now, watch out for the variable scope.
I'll strip out the finally block and try to print the number outside the try block. Red squiggle, the name number does not exist in the current context. I declared it inside the try, so it died with the try.
Correct. Scope ends at the closing brace. The fix is to declare the variable before the block.
Declare before, assign inside. Now number survives the structure. It's persistent, I respect persistence.
Now, there's a tool you've been using that wraps this whole concept into one line. int int.TryParse.
The TryParse pattern, I'll swap out the whole try catch for a single line. Ah, the out keyword. We were told to use it, but never why. It returns a bool for success and writes the result to the out parameter.
That's the TryParse pattern. It catches the format exception internally. If parsing fails, it sets the out parameter to 0 and returns false. No exception ever reaches your code.
Oh, we've been using exception handling the whole time. It was just hidden inside the method, a layer of abstraction to protect us from the mess.
Exactly. Exceptions are for unexpected failures. For things like parsing user input, failure is routine. TryParse handles that without the overhead of creating an exception object.
So you use parse when you need to know exactly why it failed, and TryParse when you just need to know if it failed.
That's the skill, knowing when to reach for each one. Once you see the pattern, you'll spot it everywhere. Try, get, value. Try, dequeue. It's an intentional design vocabulary.
Tucking the complexity inside the method so the caller doesn't have to think. A very effective strategy for managing a system, if only everyone followed that principle.
Write a division calculator, ask for two numbers, parse them, and handle the failure cases. Wrong format, number too big, and dividing by 0. Then try rewriting it with TryParse. You'll feel the difference immediately. Don't just watch it, do it.